Okay, practice test. Question number 1, determine whether the function y equals 16 times 3/7 to the x represents growth or decay, and list the corresponding growth or decay factor. Is this growth or decay? It's decay. And the factor is 3/7, which is less than 1. That's why it's decay. The object being raised to power. If it's less than 1, you have decay. More than 1, you have growth. Okay. So label each of the following as growth or decay. So A, is this growth or decay? Decay. B, growth or decay? Growth. And C, growth or decay? Decay. And because of that, and that, and that, that's the reason why they're growth or decay. Questions? Good. Let's start out on an easy note. Okay, you deposit $1,200 into a mutual fund that is projected to earn 3.2% interest annually. That's yearly, same thing. How much will you have in your account 6 years later? Round your answer to the nearest whole dollar amount, no decimals. The key to this problem, the amount after a particular period of time equals the amount we start with, 1 plus the rate raised to the t time. So on this question, I'm going to be looking for 2 major things. 1, write the equation. A equals, how much do we put in? 1,200. 1 plus 3.2%, 0.032. And for how long? 6 years. First thing I'm looking for when I grade this test is I'm looking for that. Second thing I'm looking for is the answer. Okay. 1.032 times 12. And it says, what does it say? It wants the answer to the nearest whole dollar. Read the instructions. Read the instructions. If they tell you to round it off to a particular type of answer, then round it off to that particular type of answer. You get $1,450 because it's 1449.6. So you round up.
That is not a good mutual fund.
Oh, 3.2% is actually not bad nowadays. It's not great either, though. Number 4, same idea. Initial population of 85 mice increases at an annual rate of 5%. Write an exponential function. Does it say solve? No, if it doesn't tell you to solve it, you don't necessarily need to solve it. It says, hey, write the equation. So the amount of mice I have is equal to 85 times 1 plus 0.05 to the t. We can't solve it. We have 2 variables in one equation. If you have 2 variables in one equation, you can't solve it because it doesn't give you time. It gives you the rate, it gives you the initial amount, it gives you 2 of the 4 things. To solve, you need 3 out of 4. I got 2 variables, there's nothing to solve anyways. Okay. Read the instructions carefully because I guarantee people will try to solve this even though I said don't solve it. Read the instructions carefully. Okay. Question number 5. Write the equation log base 5 of 1 over 125 equals -3 in exponential form. You're looping it. It does not say solve. There is nothing to solve. You already know what all the answers are. You're just rewriting the equation. The base of my log is the base of my exponential. What it's equal to is my new power. What I'm taking the log of is what it's equal to. Yeah. All you're doing is rewriting it. Okay. Question number 6. Okay. Different ways of solving question number 6. The one that I want to use on this one is to rewrite it same base formula. Okay, same base formula. So I have 3 to the x minus 6. 1 over 27 is 3 to the negative 3. So I have 3 to the x minus 6 equals 3 to the negative 3 to the x minus 1 power. I have 3 to some power. I have 3 to some power raised to a power. I need to make the second one just 1 power. I've got 2 powers there. What do? You multiply the exponents. 3 to the x minus 6 equals 3 to the negative 3x plus 3. 3 to some power equals 3 to some power. Set those exponents equal. X minus 6 equals negative 3x plus 3. Solve. You get all your x's on one side, numbers on the other. Subtract x. Subtract 3. Negative 9 equals negative 4x. Divide by negative 4. X equals 9 fourths. Now, there are 2 ways to do number 7. Okay, they're both closely related to each other. At the time we did this particular problem, what we would do, our first step would be to loop it. So I get 4 to the x equals 1024. And at that time, we will talk about the other methods coming up. What we did was, can I rewrite 1024 as 4 to some power? I do believe it's 4 to the 5th. Yep, 4 to the 5th. So I took 4 to the 5th on my calculator, got 1024. 4x equals 4 to the 5th. X equals 5. We will discuss other methods. And although this was the method we did at this time, if you use another method that works to solve it that we learned later on in the chapter, I'm okay with that. As long as you're doing good math to get the correct answer, I'm okay with that. This is what we learned at that time. We learned other methods going on. Okay? So, same idea on this one. First thing I want to do is I want to get the x by itself. I do need to mess around with this one first. Okay? So I divide both sides by 4. And I get x to the negative 4/3 equals 16. 16. Okay. Now, to solve this one, we have several different ways to do this. Trying to rewrite 16 to the negative 4/3 power is kind of a pain in the butt. I can do it, but I've been doing this stuff for a while. Don't want to do that. It's a pain in the butt. What I would rather do is use reciprocal powers. Make x a power of 1. What times negative 4/3 gives me 1? 3/4. So I raise both sides to the negative 3/4 power. Negative 4/3 times positive times negative 3/4 gives me x to the first power. Multiply the exponents, I get a 1. That's the idea. Now I take 16 to the negative 3/4 power. Okay, the negative means that I have 1 over 16 to the 3/4. The 4 in the denominator means I take the 4th root. 4th root of 16 is 2. 2, 4, 8, 16, 2 to the 4th. So this is 1 over 2 cubed. So x equals 1, 8. Okay. Really the only good way to solve this particular problem. Yes?
I put 16 to the negative 3/4 in my calculator.
Yeah.
Putting 1 over it, and I got 1/5.
Should not give 1/5 as an answer at all.
The one over it before.
No, if you put -3/4 power and you put parentheses around the -3/4, that should give you that as a decimal, which would be 0.125. Yeah, 1/8 is 0.125. Yeah, make sure you put the parentheses around your entire power when you do that. But you can't do that; it should spit it out. It'll probably spit it out as a decimal, not a fraction. Okay. So this one, expand using the properties of logarithms. So what I need to do first is I need to rewrite the cube root of x as an exponent. Cube root is 1/3. So this is the log base 2 of 9x to the 1/3. When I multiply two things, I'm going to take the log of two things multiplied. That is the log of each item multiplied being added instead. Because it's 9 times x to the 1/3. Remember, the cube root only applies to the x, does not apply to the 9. 9 is not part of that cube root. And then the last rule says that I can take my power, bring it down out in front. Take this, bring it down out in front. Log base 2 of 9 plus 1/3 log base 2 of x. And move the page up so you can see it. Next one is exactly the opposite. I want to combine them into one. First thing, any numbers in front of a logarithm, make them an exponent. Everything that's in front, bring it up and make it an exponent. So I have log base 2 of x to the 7th plus log base 2 of y squared minus log base 2 of 4y squared. Anything added is being multiplied. Anything that's subtraction is division. So anything that has a plus in front of it goes in the numerator. Anything minus in front goes in our denominator. That's all we do. And then we'll take it to log base 2 of x to the 7th y squared over 4y quantity squared. Now look at this. Can I simplify this? Yeah, I can take 4y and square it. Four squared is 16. Y squared is y squared. And then what happens to my y squareds? They cancel out. And I get log base 2 of x to the 7th over 16. Yes, you do want to try to simplify things out as much as you can. Okay. Questions before we move on? Okay. Same idea. Using properties of logarithms to evaluate. So the first thing you need to do is simplify it down into one logarithm, or I should say that's the easiest thing to do. So there's no powers, no numbers I need to worry about in front. So this is log base 4 of 8 times 2 times 32 divided by 2. Right? Everything's plus is multiplication. Everything minus is subtraction. I mean division. So your 2's here cancel each other out. And kind of, you can go like this right here anyways, because it's the same thing. Okay. So this gives me log base 4 of 8 times 32. So I do 8 times 32, 256. So can I write 256 as a power of 4? 4 to the 4th power. It's 256. Log base 4 of 4 to the 4th. did this before, I had a rule that said, hey, if your base of your logarithm is the same, if this and this are the same, your answer is the exponent. That's what we're trying to do there. Okay. So the base of the log, the base of that, it's the same thing. Okay. Same thing on number 12. Now, I have some choices. I'm going to do 12 slightly differently, but it uses the same properties. So I have log base 3. So I have 2 times log base 3. 27 is 3 cubed. Minus log base 3, 9 is 3 squared. I couldn't have done that in the previous problem because I can't write 8 as a power of 4. I can't write 32 as a power of 4. So I had to combine them up first. But this one, I can rewrite those as powers of 3 and simplify them first. So this is 3. So I have 2 times 3 minus, and this is 2. 3 times 3 is 6 minus 2 is 4. Or you can combine them up into one logarithm and you'll get the same thing. And you'll end up with the same thing in the end if you combine them up in one logarithm. Okay? Sometimes it's easier to simplify them first. Sometimes it's easier to put them together and then simplify, depends upon the problem. Either way would work. Okay. 7.5, solve the equations for x. Your first one, each one of these is a little different. The first one, I have to combine them up into one logarithm. So using the rules of logarithms, it's plus, so that means I have log of 3 of 4 times x minus 4 equals 3. Now loop it. Now we loop it. 3 cubed equals 4 times x minus 4. And solve. Distribute, rewrite 3 cubed is 27. 27 equals 4x minus 16. Add 16. (43) equals 4x, divide by 4. X equals 43 over 4. Next one. Can't loop because there's nothing to loop. In order to loop, I have to have a logarithm or an exponent equal to a single number. I can't do that here. Okay? I cannot write 125 as a power of 6. 6 squared is 36. 6 cubed is 215. 125 is between those two numbers. No, even power of 6. So here's what you do. Take the log of both sides. Take the log of both sides. So you get the log of 6 to the 3x equals the log of 125. Bring the power down out in front. 3x log 6 equals the log of 125. Divide both sides by 3 log 6. X equals 0.898. The 3 decimal places. What base is the logarithm we're using? What kind of log is this? It's a common log, which is base what? Base 10, why do we use that? Because it's what our calculator uses. This would work with any logarithm, but we use that because that's what our calculator uses.
Can you just divide by log 6 and then divide by 3 after?
Yeah.
Afterwards?
Yeah, you can do that first. It doesn't really matter. I just did them by the order they appear. No, you have to take the logarithm first. Take the log of 125. Yeah. Yes. Okay, next one. Loop it. First thing to do, get rid of the logarithm. It's not a common log, so I can't do anything with it. Loop it. So that means 3 to the x is equal to 84.6. This really kind of sucks. I can't write 84.6 as some log, so some power of 3, so I have to take the log again. You're saying, but we already had the logarithm, but it wasn't a common logarithm. It wasn't something you could easily do on your calculator. So you want to do easy things on your calculator. Take the log of both sides. Okay, bring the power down in front. X log 3 equals the log of 84.6. Divide both sides by the log of 3. And I get x equals the log of 84.6 over the log of 3. And you pull out your calculator. .00395, which rounded off to 3.040 when you round it off. Number 16, the population of Sacramento is about 470,000 people. If it is forecasted to decline at a rate of approximately 3.25% annually, how many years will it take for the population to reach less than 400,000 people? State your answer in whole years, no decimals. So we go back to the problem we did earlier, where we have to write the equation. I gave the equation for rates changing, exponential change. 400,000 equals 270,000. 1 minus because it's depleting. 1 minus 0.0325, 0.0325 to the t power.
It's 470,000, not 200.
You're right, thank you. 470. My bad. Okay. So I need to solve for t. I need to solve for time. This is an exponential. I need to get that part by itself first. My first step, divide both sides by 470,000. Those cancel. And you get 0.85106 3, blah, 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 blah. Notice I'm not rounding it off to 2 decimal places. I'm carrying many more decimal places than I need.
Wait, what did you just divide?
400,000 by 470,000. I more decimal places than I need by a lot. Equals 1 minus 0.0325, 1 minus 0.0325, or 0.9675 to the t. Take the log of both sides.
Wait, can you just explain that? Sorry,
It's being raised to the exponent. It's not times t, right? It's times t, yeah. Then you can just divide. That would be easy, wouldn't it? That's algebra 1. We're in algebra 2. Harder. Yes.
What happened to the 1 minus
It-
28? Did you?
I did 1 minus 0.0325. This is all within the parentheses, right? So that means that whole thing. Okay. Log both sides.
This is all in parentheses.
Okay, guys? Yeah. So now I take the log of both sides, bring the t down out in front, so I get t log of 0.9675 equals the log of 0.851063. Divide both sides. Log of 0.9675. And I get t equals 4.88, but go back to the original question. How many years will it take for the population to reach less than that? That tells me how many years to get exactly that. So I want less than that, which means I need to keep going, right? To the nearest whole year. So my answer actually should be what? 5 years. 5 years. Okay, because that tells me 4.88 is when it gets to 400,000 people. I want the nearest whole year, it's less than that. So 5 years, nearest whole year, it's less than that. Okay? Does that make sense? Okay, and then the last part. Performance task. Step number 1. Plot the points and draw a line through them, or draw a curve through them. Through a curve. Is that a hint? Should not be a straight line. Yet. Plot the points. 0, 1, 1, 4, 2 16s like up here, and you draw your curve through it. You can also change the scale if you want to, of the vertical one. If you want to change the scale on the vertical, it's fine. But we also have been talking about exponentials. This is what exponentials look like. Is it growth or decay? As I go from left to right, is it going up or down? Up. It's growth. As my x increases, my y also increases. Therefore, it's growth. Even by the points, I can tell it's growth. Okay? Using the graph, complete the table of the key points, filling in the missing 2 points. So, well, this one's easy because this one's 2. Because that's one of the coordinates. How much am I increasing by each time? I'm multiplying by 4. So 16 times 4 would give me 64. What am I multiplying by each time again? 4. So my equation would be y equals 4 to the x. And if you're not sure, see if it works. If I put 0 in there, what do I get? 1. Easy. If I put 1 in there, what do I get? 4. If I put 2 in there, what do I get? 16. Seems to work. Probably your best bet. Okay. Questions?